Okay, so let's get right into it. The world of AI right now is just exploding. We're not really building one single giant AI that knows everything anymore. Instead, what we've got is this whole ecosystem, a whole universe of specialized models, and each one is basically a genius in its own little world. But that brings up a really interesting question. I want you to think of it like an AI zoo. Seriously, you've got your math wizards in one corner, your coding prodigies in another, and then you have these incredible artists churning out photorealistic images. The open source community has just gone to town, fine-tuning thousands of these models. The diversity of talent out there is absolutely incredible.
And that is the billion-dollar question we're digging into today. How do you take the brain of a math genius and the brain of an AI that can browse the web and actually fuse them together? What if you could literally breed a new AI that inherits the best traits from all its parents?
So yeah, this boom in specialist AIs is, on one hand, an amazing opportunity, but on the other, it's a huge headache. The opportunity is that we have this massive library of skills just sitting there ready to go. The headache is, well, how in the world do you combine them without making a complete mess?
And look, this isn't just some abstract idea. We're talking about real models. You've got things like Wizard Math, which is brilliant at solving tricky word problems. You've got these agentic AIs that can actually navigate websites to get things done for you. And in the image world, you have models tuned for perfect photorealism, and even some that are experts in other languages, like understanding Japanese prompts. The variety is just staggering.
Now, your first thought might be, well, why don't we just, stitch them together? But it turns out, if you're not super careful, you don't get a super genius. You get an AI Frankenstein's monster, a clumsy, awkward combination of parts that just don't work together. Let's take a look at why that is.
The official term for this is model merging, and the whole appeal here is that you can combine skills without having to do a full, incredibly expensive retraining, which can take weeks and cost millions of dollars. So it's a shortcut, but it has to be a really, really smart one.
The old way of doing this was, well, pretty clunky. You'd have to manually decide something like, okay, let's take the first 10 layers from Model A, and then we'll tack on the last 22 layers from Model B. You're forcing these really rigid artificial boundaries, and that just completely limits how creatively their skills can actually blend.
The biggest danger with this kind of clumsy approach is something with a very dramatic name: catastrophic forgetting. It's exactly what it sounds like. In the process of learning a new skill from another model, the new, merged AI completely forgets what it was originally good at. Your math whiz suddenly can't do basic math. It's pretty much the ultimate failure of model merging.
So how do we fix this? Well, a team of researchers at Sakana AI decided to look for a better blueprint. And they found one in the most powerful design process on Earth: evolution. They built an algorithm they call M2N2, which stands for Model Merging of Natural Niches, and it basically breeds AI models instead of just building them.
And what's so cool is how closely it mimics what happens in nature. First, it gets rid of those rigid boundaries, letting the AI genes mix in totally new and interesting ways. Second, it creates competition, a real survival of the fittest for models to make sure only the best traits get passed down. And third, it has this system for smart matchmaking, kind of like an AI dating service, to ensure the best parents get paired up.
You can really see the difference here. Instead of some person making a fixed, manual cut, M2N2 dynamically figures out the absolute best place to make that split. It lets the evolutionary process itself decide where Model A's brain should end and Model B's should begin. And the result is a much more natural, much more powerful combination.
Now, this survival of the fittest part, it's a stroke of genius. Every single data point in the training set is treated like a limited resource. Models have to actually compete with each other to solve them. And what that does is it prevents one really dominant model from just taking over everything. It makes sure that the specialists, the ones who are uniquely good at certain tricky problems, survive and get to pass on their genes. It's all about preserving that diversity.
And finally, you've got attraction. This is the AI matchmaking service I was talking about. The algorithm actively searches for two parent models that cover each other's weaknesses. It's basically asking, okay, which model is really good at the exact things this other model is bad at, and then it pairs them up. It's all about breeding for skills that complement each other.
So the theory sounds amazing, right? Borrowing ideas from millions of years of evolution. But does it actually work in practice? Okay, let's get to the results and see how this thing really performs.
This, for me, was the first big wow moment in the research. They started with a population of completely random, totally useless models, basically just digital noise. And just through this process of breeding and competition, M2N2 was able to evolve a capable image classifier from nothing. And as you can see, it totally outperforms the other methods.
But the big question is, does this scale up to the giant AI models we use today? Well, they tested exactly that. They took Wizard Math, the math expert, and merged it with Agent Evel, a web browsing agent. And this table really tells the whole story. The specialists are amazing at their one thing, but fail completely at the other. But the M2N2 merged model, it scores really well on both, creating a genuinely multi-talented AI with a much better average score.
Okay, so the next test was even more ambitious. They took 4 different image generation models, 3 trained mostly on English and 1 specialist model trained on Japanese, and they basically just threw them all into this evolutionary soup to see what kind of new creation would emerge.
And the results are just stunning. When they prompted it to generate an image of a bike's registration area, the new merged model didn't just create an average of its parents, it produced a more photorealistic, more accurate image than any of them could create on their own. It understood the prompt better, and it had better artistic skills. This is what you call an emergent capability. The child is literally greater than the sum of its parents.
But here is the craziest, most surprising result of the entire paper. The entire breeding process was guided only by how well the models performed on Japanese prompts. You'd expect it to forget English, right? But the final model was perfectly bilingual. It understood English just as well as Japanese. It completely avoided catastrophic forgetting and somehow fused the language skills of its parents into one coherent brain. It learned a whole new skill for free, just as a byproduct of this intelligent breeding process.
So what does this all mean for the future of AI? I mean, this really points to a radically new way of thinking about how we build and improve these systems.
Let's just quickly recap why this is such a big deal. First, this gives us a much more efficient way to build really powerful, multi-talented AIs by just using what's already out there in the open source world. Second, it lets us combine skills without that super expensive retraining. And crucially, it seems to solve that massive, catastrophic forgetting problem. And maybe most importantly, it just goes to show that when it comes to complex design, nature is often the best engineer.
And that kind of leaves us with this one big, provocative final thought. For years, we've been building AI like we're architects, designing a skyscraper. You know, very meticulous, very top-down, very rigid. But maybe the future of AI is less about being an architect and more about being a gardener, or maybe a selective breeder. It's about creating the right environment for intelligence to compete, combine, and ultimately evolve all on its own.